APIs, by their very nature, are designed to be, automated and used by machines, which also makes it easy for attackers to kind of automate them and automate attacks and things like that.
From Toro Cloud, this is the Coding Over Cocktails podcast, a free pool of thoughts and ideas from IT experts, thought leaders, and authors, sharing their insights and advice for individuals architecting solutions for the ever-changing landscape of enterprise tech, digital transformation, and more.
Welcome to episode 79 of Coding Over Cocktails. My name is David Brown. Our guest for today is the author of API Security in Action and an experienced security architect. He has more than 20 years experience as a software developer and security professional and has a PhD in computer science. An active member of the OAuth working group at the IETF, he has a deep knowledge of internet security protocols and applied cryptography. Until recently, Neil was the security architect for ForgeRock, a leading IAM vendor, and now runs his own training and consultancy business. In his spare time, he plays guitar and cycles, hangs out with his wife and daughter in the UK Cotswolds. Joining us for a round of cocktails today is Neil Madden. Neil, how are you doing?
I'm doing great, thanks. It's good to be on. So looking forward to it.
Yeah, thanks for joining us. Just before we join, you said you've just moved into a new premises and you're surrounded by boxes still waiting to be emptied. So nothing worse than moving house.
Yeah, it was pretty stressful. So it was the buying and selling process in the UK is kind of crazy if you don't know it. So you don't really know you're moving house until like a week before it happens, and then a bit of chaos ensues. So yeah, it was kind of fun time.
There's nothing worse than moving. Well, look, let's jump into the real topic of conversation, which is security and APIs in particular. Let's just start off by discussing what the threats and vulnerabilities that publishers should be aware of with APIs.
Right. So API is a very broad term, application programming interface. And, there's obviously lots of APIs you use locally on your machine to talk to the operating system and to talk to libraries and things like that. But the book is really about web APIs. So APIs that are made available remotely over the internet using web technologies. So specifically, mostly RESTful APIs, so HTTP APIs using JSON normally. And so because they're using web technologies, you've obviously got all the most of the vulnerabilities you'd have to worry about for a traditional web application are still relevant, lots of them. Some of them are less relevant. And then you've also got things that are more specific to an API. So APIs, by their very nature, are designed to be, automated and used by machines, which also makes it easy for attackers to kind of automate them and automate attacks and things like that. For example, the OWASP, the Open Web Application Security Project, great resource, by the way, if people are looking for security stuff. They publish traditionally, a very famous web security top 10, which is like the top 10 threats you should worry about for security. And they've also recently now started publishing an API security top 10. So that's a really great resource. And they kind of list these 10 things. So, the top one is something called broken object level authorization, which is a really classic API vulnerability. So this is sometimes also called insecure direct object references, or IDOR.
Sounds very technical. Can you give us a top-down version?
Yeah. So what it basically is like, imagine you were writing like your own email server, like, you're going to rival Gmail or whatever. And so you've written an API which allows users to like log in and then check their messages. So you've got a slash messages endpoint. And so Alice logs in and she goes to slash messages slash Alice and she reads her emails, and the API is checking, is she allowed to access the messages API? And yes, she is. So it returns her emails. But if that's all it's checking, then what Alice can do is can just change that URL to like slash messages slash Bob or something like that, and obviously often in APIs, these are quite predictable URLs. And if the API is just checking, can she access the messages API and not checking whose messages specifically she's trying to access, then she might then get sent back Bob's email messages. And this sounds like a really simple thing and an obvious thing, but actually this is really prevalent in APIs. And so those kind of things are like, you really need to worry about. And they list a whole bunch of these things that you have to worry about. So another classic one is overexposing data in your API. So, returning sensitive information in APIs because you're not really, your UI is taking that API response and then maybe rendering a subset of it. And so nobody's actually testing what the underlying API is returning. And it turns out, it's returning your social security numbers or, credit card details or whatever. Right. And so there's lots of things like that to worry about.
Yeah. All right. That sounds like a good resource as well. We'll publish that in the written version of this podcast as well. Run me through the security mechanisms for an API.
Right. So in the book, I kind of cover the standard kind of mechanisms that would be used to protect against like whole classes of threats, because you don't want to be kind of going down the path of like reacting to individual security vulnerabilities. So you want to make sure you've got these kind of core security mechanisms in place which kind of stop broad classes of attacks straight away. And there's kind of 5, if I can count here, 5 main security mechanisms. So there's kind of initially you have some kind of encryption on your connection, so you're using HTTPS, and that's kind of protecting data, in transit to and from your API. That's kind of a basic thing that most people would have set up now. You then potentially also have encryption on your back end of encrypting data at rest, depending on the environment you're storing it in and your threat model of how worried you are about people accessing that. So you're encrypting on the back end. And then there's kind of like a bunch of stages of security controls that requests go through as they reach your API. So typically there's some kind of rate limiting, which is just a mechanism that just prevents your servers getting overwhelmed. And it's designed to stop denial of service attacks, particularly things like distributed denial of service attacks, where people kind of recruit a huge botnet of compromised machines and have them all flooding your API with traffic. Right. And so you have just some kind of like rate limiting, which is going to like realize when there's too many requests happening for your service to handle, and it's going to start shedding load at that point, or throttling requests, which is kind of delaying them until later. And that is often performed, at the network layer. So you kind of push that out as far to the edge of your infrastructure as possible. So right out to, and if you're really worried about DDoS attacks, then you might employ a commercial services company that provides, DOS protection. But otherwise, you're kind of doing some kind of rate limiting at your kind of edge load balancers, and then, at layers within your system, so that you're kind of blocking these requests. And then beyond that, you're then looking at authentication. So working out who is sending this request to your API. And that can often be quite different in APIs to how it is in traditional web applications. And we'll maybe go into that a bit later. But you've got this authentication process which kind of like works out who the user is, basically, that's making the request. And then through that, you've then got logging. So you have some kind of security or audit log that's recording all requests to your API, so that you can then later work out who did what on the system. It's very useful resource, particularly after an attack, to be able to go back and see, oh, well, if an attacker did get in, what did they access, and things like that. And then you have your authorization, where you actually make a decision of whether this user should be allowed to make this request. And this is where you would fix those broken object level authorization issues we just talked about. So you have some decision process there, which is saying, who's making this request? What are they trying to access? Should they have access to that? And potentially other things. Some APIs, might have, on-call shift rotors, and so certain users can only access the API at certain times a day, and things like that. And that's kind of like your main kind of stages. So you've got encryption of data to protect it. You've got the rate limiting, authentication, logging, and authorization. And those are the kind of main mechanisms to get right.
Got it. In your book, you also mentioned that security flaws often occur when an attacker can submit inputs that violate your assumptions about how your code should operate. Can you give me an example of that?
Yeah. Well, we've already discussed one with these insecure direct object references. So in that case, the API is kind of assuming that if you're accessing the messaging API and you're allowed to access the message API,
right,
that you must be accessing your own messages.
Mm-hmm.
Because maybe the UI only generates links to your own messages, right? So nobody's going to go and fiddle with the URL or whatever. So that's the kind of very basic assumption. But there's also other things that can occur. There's things like so there's a class of like denial of service attacks, which caused memory exhaustion attacks. So some APIs which take like binary format messages, the message comes in and it has like a length field which tells you how long it is, and then the actual message itself. And if you don't, validate that length field, that might be like a 32-bit length field or whatever. And if you just blindly allocate a buffer that size to hold the message, they can just send you like the maximum possible value, and your API is now allocating like 2 or 4 gigabytes of memory blocks for each message that comes in, and it means they can just send a few messages and totally take down your API. Right. So again, there's an assumption there that you're making that people will only the length will be correct and will match the message, whereas it won't. And in fact, it was a classic security vulnerability, Heartbleed, years ago in SSL, which had kind of pretty much exactly this vulnerability where there was this little used part of the SSL spec, which was an echo thing. So you could send it a message and it would send you back the same message back to you as a kind of heartbeat thing to check whether the server was up. And hardly anyone used it. And it had exactly this vulnerability that you could just say, well, yeah, this tiny message is actually 2 gigabytes long, and because this was written in C, which is not a memory safe language, what actually happened then was it assumed the message it got in memory was 2 gigabytes long when it was only tiny, and so it would take a whole chunk of the server's memory and then send that back to the client, and that memory was like the private memory of the server and contained like private keys and passwords and all kinds of stuff like that. So that was a terrible vulnerability. So again, it was just an assumption made by a developer at the time that the length is going to match. Why wouldn't the length match? And so it's kind of like and a lot of attacks go on very subtle differences in the assumptions that the developer made when they wrote the API compared to how an attacker actually abuses it.
I mean, your book has amazing resources when you're developing APIs to look at ways of securing them and considerations taken into account of the design. Of course, a lot of companies are already published an API. Are there any frameworks or tool sets that can assist them with the identification of threats?
Yeah, so there are various things. So there's things like I'm going to struggle to think of names now, but there's first of all you need to kind of understand what APIs you actually have, which is a common problem that companies have, that it's quite easy often to just deploy an API. And so you end up, particularly in the early stages of a company, with lots of APIs, and you don't necessarily know what they are, who's responsible for them, even where they are. So you have tools which can kind of scan your public kind of cloud offerings and your known IP address ranges and things like that, and they can discover APIs and inventory them so that you can then start, tracking down who owns this thing, what security controls are already in place for it, and things like that. There are then things like there's various kind of appliances you can kind of put in front of your APIs, which will kind of block various attacks. So there's things like web application firewalls and things like this, which sometimes now built into things like API gateways, where they have kind of rules that will detect various kind of common kind of attacks. And sometimes they can kind of like feed in kind of information about new attacks as well that are ongoing, so you can kind of keep them up to date.
Okay, and you let's talk about the secure development. So when you're creating APIs from the outset, what coding practices can a developer use to avoid incorporating security vulnerabilities?
Right. I mean, this is a huge area. There's many possible things, and people have written a lot on kind of secure development. But there is some kind of basic things to kind of look over, and I kind of go in the book over some basic kind of secure development principles. So things like, if you're coding your API in a memory unsafe language like C or C++, then there's a lot more things you have to worry about. So ideally, if you can, use a memory safe language like Java or Rust or Go or something like that. But if you have to use C or C++ for whatever reason, then there's a bunch of things you need to do to kind of make sure you're not having those kind of heartbleed style vulnerabilities where you're getting buffer overruns and things like that. And there's a bunch of nice tools now that you can run. So Clang, which is kind of the C compiler, has a bunch of tools in it, these kind of sanitizers you can run, which will tell you, they kind of instrument your code when it's compiled, and then they detect certain conditions that are risky and will kind of tell you. So they'll detect things like buffer overflows and undefined behavior. So that's things you're doing in your code that are sort of compiler specific, how they're going to behave and might change on different platforms and things. So then beyond that kind of basic kind of getting the memory safety right, there's then a bunch of things, and there's kind of like categories. So one of the most dangerous things you can do in security is parse anything, basically. So many security vulnerabilities are around parsing, which kind of feels weird because parsing is kind of one of those areas of computer science that feels like it's like the most studied and kind of like there's this really good kind of theory behind it. But actually, in practice, it's really risky because often different parsers will parse things slightly differently, which can lead to vulnerabilities. So, as an example of that, there's things which are request smuggling vulnerabilities, where you have a request comes in and it's not just going straight to your API server, it's going to some kind of gateway or reverse proxy, like an API gateway, that's doing some kind of like access control checks first, and then it's going to forward it onto your API if it passes those. But if your backend server and this gateway, if they parse that HTTP request differently, this is quite a common vulnerability, then an attacker can submit a request which to the gateway looks innocuous and passes the checks, but then on the back end it gets parsed as a completely different type of request and causes something completely different to happen. So that's called request smuggling and is quite a serious vulnerability. So the main solution to that is try and keep it simple and make your data formats and things as simple as you possibly can. Even JSON, which is quite simple, there's actually people have done some work looking at the differences between JSON parsers and finding that like basically no two JSON parsers in the world parse JSON exactly the same way when you get down to like looking at all these edge cases. So there's kind of input validation, and you've got to make sure then that people aren't sending malicious things to your API. You've then got things like injection attacks. So when you're saving your data into the database, making sure that you're not just concatenating strings together to form the SQL statements that you're running to insert things, because then otherwise, or even to query things, because then otherwise the attacker then can put specially crafted strings. You've probably seen the XKCD Little Bobby Tables cartoon. If you haven't, Google that. Where somebody's got their name, they've named their child such that it's got like SQL syntax in it, and it drops the whole database when you load that child's name into the database. And so there's things like that, and so you have to kind of there's different ways you protect against that. So for databases particularly, you use something called prepared statements, where rather than just concatenating strings, you kind of have a SQL statement with just placeholders in it, and then you supply the inputs separately, and then the database knows, well, that's user input and that's the code, and so it can't get confused about the two. There's also injection into HTML, which causes cross-site scripting and stuff, and there's different ways you do that. So normally there's some kind of escaping you have to do to kind of protect values. So those are the kind of things you have to look out for. I'm just trying to think what else I cover in the book around that. But
there's a lot. I've looked at the book, and you cover a lot in this space. It's incredibly comprehensive and an easy read as well. I highly recommend it. Let's move on to authentication. You did start talking about some of the security mechanisms, and we touched on authentication and authorization, which we're going to talk about as well. So you say that token-based authentication is the dominant approach to protecting APIs. What are some of the advantages and disadvantages of token-based authentication?
Right. So token-based authentication is basically, so people sometimes have different definitions of what it is. But for the purposes of the book and how I interpret it is that you log in and you get some kind of token, which is a string, a random looking string that you then send on subsequent requests to the API, and that authenticates you. So that string is somehow connected to your account. So typically it might just be via an entry in a database. So this random string maps to, something which says, who your account is. It might link to billing information and things like that if your account is commercial, your API is commercial. And some of the advantages of that is obviously then you're not sending user passwords or other credentials on all your API calls, which is particularly important. If you have a lot of APIs and a lot of people developing them, not all of your developers are going to be, security people. And so they might not know how the best ways to handle passwords and things like that are. And so this token, which is typically relatively short-lived compared to a password, there's less risk then of it being leaked somewhere. If the API is logging that information to its logs, and it's actually logging these tokens, and they're ending up in some centralized log store, it doesn't matter so much if that token is only valid for like 15 minutes or something, or a couple of hours, compared to if it's somebody's password, which they probably reused on their bank account as well, and things like that. So that's kind of one of the main advantages. There's also kind of on the other extreme, there's kind of more secure approaches to authentication. So there's things like you can use certificate authentication at the TLS layer, but that's often really complicated to set up. So token-based authentication is kind of hitting this sweet spot where it's kind of quite easy to set up and get going, and adds quite a lot of security benefit early on, and it avoids a lot of this complexity. And then recently there's been kind of work on like improving the security of token-based authentication. So you can add additional security, things like certificate authentication on top, and kind of tie them together in a way as a kind of optional thing that you add on when you want to harden your systems later.
And so what the certificate authentication, that's where the client and server are authenticating each other based on their certificates, is that right?
Right, exactly. So a certificate is a bunch of information about who you are, and then also a public key in a kind of signed thing that you give to to the server, you do client authentication. So the server authenticates to you first with its certificate, and then you authenticate back to the server with your certificate. And the difference between a token and a certificate is that when you present this certificate, you also have to kind of sign something with a private key that only you have to kind of prove that you're the guy who has this certificate. So that's, whereas tokens are what's, the original way you use tokens are what's called a bearer credential. So it's like cash. Like if you've got it, you can use it. And there's no other check done. So, if you present that token to the API, then it's assumed that you got it legitimately. And so obviously there's a risk then that if somebody manages to steal that token, that they can use it just like you can. And so there's various things you can do to kind of harden that up, but there's a kind of trade-off then between adding more complexity to your systems.
If you're just registering a token in a database, is there any sort of scalability issues as the number of users grow and as you're issuing tokens?
Yeah, definitely. So it depends on, what technology you're using for your backend databases. There's some great databases now that scale really well, particularly in the cloud and things like that. So you can actually so people are often quite quick to jump from database back token to other forms that I'll talk about in a second. But actually, I would say you can get quite far with a database. So don't assume that you're going to, and in many ways, putting stuff in the database is the most secure thing, because it's really easy to revoke tokens. Then you just delete the entry from the database. So the alternative that people look at are so self-contained tokens. So these are so JSON Web Tokens is the main standard people use, and this is a bit more like the certificate we were just talking about. So it's a bunch of JSON that says who the user is, maybe what roles they have, when they logged in, things like this. And that JSON is then signed with a private key and encoded, and that becomes the token. And so on your API, then all you have to do is verify the signature on this thing, and that it was signed by your trusted authentication service. And then you can just unpack the JSON, and you've got all the information there. So you're not having to make any kind of call out to a database. So it's a lot more scalable, that approach, and potentially. It has different trade-offs. So, like I was saying, revocation is much harder now because this thing is just valid until it expires. You obviously have to, if you're using time-based expiration, you have to have a reliable clock, which is something that's quite often forgotten. That you've got to be able to tell the time accurately. If this thing's supposed to expire in 20 minutes or whatever, you've got to be able to know when 20 minutes is up. And if your servers have wildly different ideas of what the current time is, that can cause problems. So there's different trade-offs there. But yeah, generally speaking, most mature APIs after a certain point will move towards these kind of, they're sometimes called stateless tokens, or client-side tokens, things like this.
I know there's always a lot of confusion between authentication and authorization. So maybe you can give us a rundown. How does OAuth 2 fit into all of this?
Right. So the difference between authentication and authorization is, authentication is about, as I said at the start, it's about who you are and proving who you are. And then authorization is about, given that I now know who you are, should you be allowed to do what you're trying to do? And OAuth is kind of interesting. So OAuth is kind of like a standard approach to token-based authentication, in that you stand up something called an OAuth 2 authorization server, and your users can go to that and log in, and they'll get back a token, an access token, which they can then use to access various APIs. And so OAuth 2 is authentication in that regard, but it's not it's not in other ways. So it's designed as a delegated authorization protocol. So when you're logging in at the OAuth service, what you're actually saying is, the bit of software that I'm using, my client, which might be like a mobile app, or it might be a website I'm using, that's different from the website I'm trying to access. I'm going to authorize that app or whatever to access my stuff on this other API, but I'm going to limit the scope of what it can access. And so Auth2 has these scopes which get attached to the token, which say what you're allowed to access. So maybe if we go back to like our email example, right? So Alice has got a custom email app that she wants to use with her email server, and they're made by different people. And so she uses Auth2 to kind of log in to her email service and then say, I want to give this app a token it can use to access my emails, but I want it to be like read-only access, say. So it can only read, it can't write any emails. So that's the scope of the token. So that's the authorization aspect of Auth2. So Alice is authorizing this app to access her stuff. So she is authenticating to the authorization server, so the authorization server knows it's her, but then she's authorizing this app to access her stuff on her behalf. And then the app again gets this access token, which it uses to access the APIs. And it's kind of similar in a way because that access token will say who Alice was originally. That's in L2, that's known as the resource owner. So who originally authorized this? And the backend API is going to probably look at that at some point and say, well, which messages is this client trying to access? Is it trying to access Alice's messages or Bob's messages? I'm going to compare that to who originally authorized this token. So that's the authorization aspect. And then it will also check these scopes and say, well, if it's trying to write an email and she only authorized read access, then I'm going to say no to that.
And of course there are lots of different OAuth flows as well, right?
Yeah. New ones added every day almost. Right. So OAuth2, it's a framework rather than a specific way of doing things. And that has pros and cons. It's very flexible, but it does mean that everyone does things in a slightly different way. You get these grant flows, which kind of are how Alice kind of proves who she is to the authorization server, and then also how the token gets communicated to the client. One of the very simplest one is the resource owner password credentials grant, which is now being deprecated and shouldn't be used, where Alice literally sends a message, posts a message to or rather her client posts a message directly to the authorization server with Alice's username and password in it and gets back a token. So obviously the way that works in the terms of like, if you've got your mobile app, then what that means is the mobile app is asking you for your username and password, and you type it directly into the mobile app, and then it goes and gets a token. Now, obviously that's like completely insecure, really, except for very trusted apps, because obviously that app, this idea of scopes and limiting what it can access to. If you've given it your username and password, then it can ask for whatever scope it wants, right? Because it's got your whole credentials then, and it's kind of can take over your account. So the more secure flow that people generally use in web applications is the authorization code flow, where you redirect the user to the authorization service, and the authorization service has its own web page where it will log in Alice, take a username, password, two-factor authentication, whatever. And then it generates a short-lived authorization code, and that's really short-lived, like a few seconds, 10 or 20 seconds. And it redirects back to the client, and the client then takes that authorization code and posts it back to an endpoint on the authorization server. And then the authorization server returns its access token from that endpoint, and that's much more secure. But there's also like flows for specific circumstances. So there's a thing called like the Auth2 device flow, which is useful for things like smart TVs and things like that, where you want to kind of link to your account, but the TV doesn't have any kind of keyboard or anything, so you're not going to be able to type in your password directly on the TV, or you're going to have some horrendous people do this where you have this like little cursor and you have this on the screen keyboard, and you have to which is horrendous for people like me who use password managers with like 30-character random passwords, and you're like spending forever. So there's a thing called the OAuth 2 device flow. And if anyone listening to this is writing a smart TV, please go and find out about the OAuth 2 device flow, where basically you render like a QR code or something like that on the TV screen, which the user then scans on their mobile.
Yes, I've had that.
The mobile then loads the authorization server, and they log in and authorize the smart TV to have access. And in the background, the smart TV is it's being given a code by the authorization server in the background, and it's polling to see when the user is finished. And then eventually, the user approves it, and then it gets back its access token on that back channel. So it's kind of the security pros and cons with this, but it's usability wise, it's way better than this kind of using a cursor on your screen.
So we've covered a lot of ground, and we've been primarily talking about RESTful APIs. I'm just wondering, do all these principles we've been talking about, do they for RESTful APIs, do they also apply to service-to-service based communication, say in a microservices-based architecture?
Yeah, they do. The mechanisms you'd use might be, the specific techniques you use might be different, but the general principles are the same. So typically in the back end, it's kind of a different approach, and there's things you have to worry about that you don't have to worry about on the front end. So typically microservices are talking to each other using service accounts, so they're not using user accounts to connect to each other. My microservice will have some kind of, assuming you have any kind of authentication between your microservices, which people often don't right at the start, but you should do. But so typically you'd have some kind of service account, which, even in the simple case of like a traditional web application, you've got your application, your web server, and that's talking to a database, and it's got some kind of database connection password. So it's a similar idea, if you're talking between microservices. And that service account connection password then is highly privileged, so it can access any user's stuff. And so you do have to be careful that if somebody manages to find a way to make requests through your API, through to the database or through to a backend microservice, that they can't then access stuff they shouldn't be allowed to access. And there's a whole class of vulnerabilities there called server-side request forgery, which is, again, a horrible acronym and hard to remember. A better way of remembering it is accidental web proxy. So you've got some service in your thing that's accidentally, it provides a proxy interface that an attacker can send requests to it, and it will send them off to like back-end services in your internal network that you shouldn't be able to access. So in the book, I actually, in later chapters, I give an example of this, which is like a service that generates link previews. If you've got like a chat service like Slack or something like that, you paste a link into the chat, and it goes off and fetches that link and renders a little box with a little summary and maybe an image or something of what that web page is. And to do that, it's making, there's different ways you can do that, but a common way is that your backend service is then just taking these URLs and connecting to that URL from your backend. But if your attacker then can guess the URLs of like your internal services, like their IP addresses and things like that, then it can just feed your service URLs, which are, your billing service or whatever, or your payroll service. And then your server just blindly connects to it and like, oh yeah, here's a bunch of stuff, and I'm just going to render that into this little box. So there's kind of all kinds of subtle problems around that. So you have to be really careful particularly when your backend services are processing URLs, to make sure that you're validating those correctly.
So many considerations. The book is called API Security in Action. It's published by Manning. Where it's honestly essential reading for anyone building APIs or who've already published APIs, for that matter. Neil, how can our listeners follow you on social media? What channel should they be looking at? Is it LinkedIn, Twitter, or something else?
Yeah, so Twitter is where I'm most active. So I have the handle Neil Mad Dog. Don't ask me why. I joined Twitter late, and there was a lot of Neil Maddens on already. So I'm on
David
Twitter.
Browns there are.
Yeah. So that's where I primarily, and I kind of tweet. I also have a blog which I kind of sort of infrequently update with articles on things. That tends to be a lot more in depth. I'm also at the moment launching a business. I haven't quite launched it yet, where I'm going to be providing kind of security training courses. So there'll be online training courses and some in-person ones. So if you keep an eye on Twitter, you'll be able to see that when that comes out.
At Neil Mad Dog. Neil, thank you very much for your time today. It's been a pleasure to have you on the show.
Brilliant. Thank you very much. It's been fun.
Hey listeners, thank you for joining us in this round of cocktails. Please like and subscribe to check out other episodes of this podcast series. We're also available on your favorite podcast platforms, or you can simply listen in at torocloud.com, where you'll find full episode transcripts and show notes. On behalf of the team here at Toro Cloud, thank you very much for listening to us today. This has been Kevin Montalvo for Coding Over Cocktails. Cheers!